So today we are going to show you how to complete finite element analysis on a plane truss in ANSYS. You're going to begin by dragging the static structural into the project schematic. Then you're going to double click on engineering data, add a new material. This will be aluminum for our purposes. Then under linear elastic, you're going to select isotropic elasticity. You're going to add a Young's modulus of 69 times 10 to the 9th Pascal, a Poisson's ratio of 0.33, and then you will update the project and return to the project. Now you'll double click on geometry and wait for that to load. You're going to select your desired length, hit OK, right-click XY plane, select Look At, go to the Sketching tab, select Line, and you will draw your truss. Next, you'll click Constraints, select Equal Length, and you will select the 3 horizontal portions of the truss. This will make them all the same length and make dimensioning easier. Next, you're going to dimension the truss to your specifications. You can zoom in and you'll see your truss. Okay. Next, you're going to click on the Modeling tab, select the XY plane, Sketch 1, and you're going to select Concept, Lines from Sketches. You're going to double click Sketch 1, Apply, and then Generate. Then you'll click Concept, Cross Section, Rectangular, and then you will add your base and your height. For us it was 0.0173 meters. Then you'll expand one part, one body, select line body, cross section, and you'll select rectangle 1.
Now you're ready to generate the mesh. Double click on Model in your workbench in order to start the mechanical. At this point, the number of elements along each line segment will be specified. First, right-click on Mesh, we're going to right-click on Mesh, then click on Insert, then Sizing, next click on the Edge Selection button. It's in the toolbar. Now hold down Control and you're going to select all 7 segments. When you're complete, all segments should be highlighted in a light green color. Now click on Apply, which is located in the Details of Edge Sizing table. Now change the type to Number of Divisions. Set Number of Divisions to 1 and click Update. Expand Mesh and click edge sizing. The single yellow bar on each line segment conveys that there is only one segment per line segment. Now, to ensure that you're constructing a truss instead of a frame, you're going to click the tools, then options, then you're going to search for fixed joints and ensure that it says no. Then click OK. At this point, the two supports need to be created. You're going to click on the static structural, right click on that, then click insert, and lastly click fixed support. Next, you're going to choose your vertex selection button. Click on the top left corner of your truss. Now click on the apply button in the detail of fixed support box in order to apply the fixed support to the vertex. Now repeat the steps for the second fixed support. Now you're going to create your point load. You're going to right click on the static structure, then insert, then force. You're going to select the top right corner of your truss and change the vector to components. You're going to type in 4,000 newtons for the X component and a negative 10,000 newtons for the Y component. Then we expand the geometry. Click apply. We expand the geometry. Click on line body, and we're going to assign the material. The material assigned is aluminum.
Alright, so the objective of this tutorial is to determine the unknown nodal displacements, the unknown reactions, and the actual stress in each bar member. To determine the unknodal displacements, we're going to right click Solution, Insert Deformation, Total Deformation. Okay. We're going to repeat that for the directional deformation, so we're going to do that in the X and the Y axis. So we're going to click Deformation, Directional Deformation. Make sure this is oriented to the X axis. Okay. We're going to do that again and have a second directional deformation. This time we're going to change the orientation to the Y axis. Now we're going to determine the unknown reactions. We're going to select Solution, right click, Insert Probe. We're going to click on Force Reaction. Okay, make sure this is for the fixed support 1. We're going to do the same thing, Insert, Probe, Force Reaction, and assign this as the fixed support 2. Okay. Finally, we're going to determine the axial stress in each bar member. Right click Solution, Insert, Beam Results, and Axial Force. Okay, to determine the axial stress in each bar member, we're going to divide the axial force that we get here by the area of our cross-section. Okay, we're going to right-click Solution and Solve. This is going to solve all of this for us and give us values. So when we click on Total Deformation, we're going to see that it comes up in colors and it gives you solutions for each different node. As for the directional deformation for the X, directional deformation in the Y, your force reactions, and your axial force. Okay, this concludes our tutorial on the finite element analysis of the plane truss. Thank you.